welcome to everybody. This Snack and Learn webinar will be about the subject of local soil improvement in construction while lowering emissions and saving virgin construction materials. It is a big subject, so my presentation will focus on one case to narrow the focus and keep the time. My name is Isak Hjortdam and I am with WSP Denmark. I'm an environmental advisor and I'm part of the Earth and Environment Division of WSP. And I've brought to this slide some information about the Earth and Environment section. Our core businesses are environment, natural resources, nature and offshore, urban development, and climate adaptation. Where I'm situated in Denmark, we are 270 staff, and globally in E&E, we are 21,000. We're present in 40 countries across 6 continents. And with that, I'm going to dive straight into my agenda for today. I'm going to go through a background of the topic, talk about some local requirements. This will mostly be about legislation. I'm going to bring you through a specific case we've done, while also showing you results of different LCA screenings we have performed. And then I'm gonna talk to you about a local resource site, give you some insights to the benefits and challenges, walk you through the process, and finally I'll end off with the conclusions. So for the background, first of all, I just want to say that this photo is not really from a construction case. It's from a big site remediation we did. I brought it because I thought that the excavator looked funny. But in all seriousness, this also is a good case as to how we do construction processes that has to do with excavation in Denmark. We excavate, we put it on a truck, the excavated excess soil. We drive it often along great distances to dispose of the soil, and then we bring in new raw materials, which are also transported along long distances. So, raw materials for construction, such as sand, gravel, rocks, are a scarce resource in Denmark, and disposing of it doesn't really play well with circularity in construction. Because of that, or we want to change that and reuse soil from construction, which is what this presentation is about. I'm going to narrow it down to utility companies projects, so that would be projects like district heating, sewer systems, or water piping, such as that. And when I talk about soil, I need to also discuss the resources around it. So we discuss or define soil as typically containing sand, gravel, and stones as well. And I'm going to talk about all the 4 terms because sand, gravel, and stones are typically the raw materials that we bring in to a construction site, where soil is what we typically expose of. So, how do we handle soil, excess soil from construction and excavations traditionally? Well, that's what I just mentioned before. We excavate it, and if we don't have a specific need for it, and often it's difficult to reuse it straight away, then we dispose of it. And why do we consider it waste? That is something to do with Danish legislation where I'm working, but also the fact that it can be difficult to reuse it straight away. And then sometimes you have to manage it on the site for a while, which might take some permits and make everything difficult. Often we see when we want to dispose of soil, at least in Denmark, that the receiving sites of this excess soil, they have limited capacity. So sometimes our projects comes to a halt because we simply cannot dispose of the amounts of soil that we need. And then on the other hand, the natural resources we need to bring back into the project, such as sand, gravel, and stones, are a scarce resource. We have been looking at this problem from different angles, and when we look at a CO2 emissions point of view, we actually see that the transport to and from the site with excess soil and to the site with raw materials, that pose large proportions of CO2, and I will show you some calculations to back up this claim. In Denmark, when we do utilities projects, they're typically in roads, which leads to a specific legal framework that I will touch a little bit more upon. So, Local requirements. Here we see again another construction project we did with a client, and all the soil were disposed of because it was difficult on that project to reuse it. How you can reuse it and to which degree will probably be highly dependent on local legislation, which is country specific, but we also sometimes see it that it's even municipality specific. So an example from Denmark is that when we do projects with utility companies, it's typically in the road cadastre, which by default is defined as contaminated. And when it's defined as contaminated, it imposes difficulties with regards to material circularity because when it's contaminated, it's treated as garbage. So you need to dispose of it instead of reusing it, even though it's perfectly geotechnically sound. So, for all of you listeners, both from Denmark and from other countries, my recommendation is this: stick to the principles and the ideas that I present and not the legislative details, because these vary from country to country, and within Denmark, they even vary from municipality or area to other municipalities and areas. I'm just going to jump into the case. This is a town called Vedelev. You can see where it's situated on the map of Denmark in the bottom of the slide. In this project, the local utility company Force are planning to do district heating in the coming 3 years. For this project, they plan on producing between 15 and 20,000 tons of excess soil. We did some calculations for the utility company, and we looked into the possibility of making a site close to the city where we could treat the excess soil so that it would be suitable for reuse within the same project. And if we went ahead with that, we projected a cost savings of around 12.5%. And to make this cost saving question a little bit more specific, I'm just going to mention some similar calculations we did for an adjacent municipality. For a same type of project, we were able to display savings of between 15 and 20 million Danish kroners over the entire project, which corresponds to 2 to 3 million US dollars. So another very exciting note is that we found that if we were able to make this local site for soil reuse and improvement, we could potentially save up to 70% of CO2 equivalent emissions. Of course, I'm going to show you some numbers on that as well. And what WSP has delivered for the company is some circular economy advice. We did a feasibility study with the numbers that I just proposed, and then we're currently undertaking the permitting phase. And so just briefly to touch upon how is the soil improved if we bring excess soil from this district heating project to the site. There are numerous ways of improving it. What we want to make sure is that there are no environmental toxins in the soil and that it is geotechnically sound for reuse. And with regards to the environmental questions, we sample the soil on site and we dispose of soil that might be heavily contaminated and not fit for reuse. With regards to geotechnical stability, the contractors running the site can add either sand or cement or burnt chalk to improve the load-bearing capacities of the soil so it's ready for reuse. Now I'm going to walk you through some of the numbers we made. We made some different LCA screenings of different scenarios. These photos on the slide shows roughly how a district heating project is performed. You cut through the road, you excavate, you put in a pipe, and then you fill it all back up and finish the road. And as I mentioned, the business as usual is excavating, putting on trucks, and transporting often quite far away. This slide shows the distance from the site to a site in Copenhagen, the capital of Denmark, where we used to dispose of a lot of soil, and the distance is a little more than 50 kilometers, which corresponds to around 35 miles. Then we move back to the Vedelev case, and you can see that the green square in the bottom right of the photo shows where we want to make the site. and how that is in proximity with the town. And here we have a Google Maps distance of a little more than a kilometer, which is a little less than a mile. So those are the two main differences, because we focused on transportation of materials as the main emission factor. So we made an LCA screening with different scenarios. So the leftmost column shows business as usual, meaning excavating excess soil, disposing of it as at a receiving site, and then bringing back new raw materials to finish the construction. And if you look at the orange part and the pink part of the column, you can see that those two are the highest amounts of CO2 emissions. The orange one is transport away from the site with excess soil, and the pink one is transport to the site with raw materials. The green part of the column is the construction machinery on site, and then the blue part is the production of the materials needed for the construction. So what we can see is that transportation is like a low-hanging fruit as to where we can set in to lower the emissions of the project. The second column that I'm pointing to with my mouse is where we reuse 85% of the soil that we excavate. This is a number that we have from construction for projects out in the real world. So this is definitely doable. And in this scenario, we don't use any burnt chalk to stabilize, so only sand and gravel. And in this case, we are set to save around 60% of the CO2 equivalent emissions. So the next column is the same amount of reuse, the same site, but we add 0.5% of burnt chalk to all of the soil that we reuse. This is to geotechnically stabilize the soil, and 0.5% is something that's definitely realistic if you need to add burnt chalk. And in this case, we still save around 50%. Then to the furthest right, we see the same amount of reuse, but with 2.0% adding of burnt chalk. This is something that people actually do. I would say that it's not necessary to add 2% over the entire 85% of reused materials. And if we do so, we can see that there are actually higher CO2 emissions than if we did it business as usual. So we went to the client with this and said they can have improvements in CO2 emissions if they use the local site. They can still have the financial improvements, but we cannot guarantee the CO2 benefit by doing it this way. We also mentioned that we did some conservative assumptions, saying that we disposed of the soil at a 40-kilometer distance instead of the actual 52, which was the real case. But that's just to make sure that our calculations would still be showing the right trends. So the client said that they actually never used the site in Copenhagen. Instead, they drive it south to a place called Masnedø, which is a little less than 100 kilometers away, which corresponds to something like 65 miles or so. We went back to the desktop and performed some new LCA screenings. All the columns are the same, only the distance traveled is increased. And in this case, we actually see that the business as usual is the worst case. So even if we add 2% of burnt chalk to the entire amount of soil, it's still in a CO2 emissions view a better way of doing things. And now it seems that if we can improve the soil without adding burnt chalk, we can save up to around 70% of CO2 emissions. And so how do we do it? We do it on the local site, which I have some photos of here. And of course, the site needs to be as close to the construction process as possible. In this case, in the Videlev case, we're a little more than a kilometer away, which is what our calculations for the LCA screenings are based off. But I've seen numbers from other companies suggesting that if you are within 15 kilometers, so that would say 10 miles, it would still be a benefit from a CO2 standpoint. These sites can be very simple. The one that I have shown pictures of is one of the simple ones, and simple as possible. In the bottom left, you see the facilities for the people working there. In the bottom right, you see in the left part of the picture big piles of soil that is excess soil from a district heating project in the vicinity. Then you see a sorting machine, and in the top photo, you see the same sorting machine, while you see on the right side of the photo a tent. In this tent, the little excavator brings in all the soil that's not geotechnically sound, meaning it doesn't have the needed load-bearing capacities. And in that tent, burnt chalk is added to stabilize the soil and shelter um, the soil that has been improved from water if it rains. Here I have a photo of a newly constructed resource site, which is meant to last for 10 years. And even though this looks a little bit more fancy, you can see that it's basically the same. This leads me to the benefits and challenges. So as benefits, obviously there are CO2 equivalent emission savings and cost savings. But another benefit that I haven't touched so much upon is the guarantee of progress of the project, because in Denmark at least we don't always know how much soil a receiving facility can take, or how much raw materials we can get from a gravel pit. And we've actually seen projects that had to be put to a halt because either we couldn't dispose of enough soil to continue, or we couldn't bring in the raw materials needed to continue. And when you do a construction project with a local site for improving the soil, when you progress fast, you put a lot of soil into the local site, which can then be improved and managed and be put back into the project at the same pace. So if you produce much, you can have a high pace of production, and if you produce slowly, you can have a slow pace. So these two kind of follow along and makes the progress easier to guarantee. Then another one is less heavy traffic on the roads with big trucks when you do projects with these local sites. Less heavy traffic means less road wear, less accidents, less air pollution. And when I've been talking to the local habitants close to projects like this is actually the thing that they care mostly about, is the lower amounts of heavy traffic on the roads surrounding them. Then we have to cover the challenges, because of course this still comes with challenges. You have to plan a little bit in ahead, because there can be a heavy permit load compared to doing business as usual. In Denmark, this is not an entirely straightforward process, because there is a legal framework that we have to follow, and that makes it in some ways a little bit more difficult. But the biggest challenge that we actually face is the phrase, "but we're used to," because if we want to succeed with a different approach, people have to jump on board and be ready to change the ways they work. With this, I'm going to show you some insights to how this process is going along. And what I would say first is, all in good time. Prepare earlier than you would normally do, because this is a longer process than the business as usual. When you define the project, do an early stakeholder reconnaissance, because this is very important to get all the insights you can to the specific project. Include the planning and environmental authorities as early as possible, so that you're making sure that you apply for all the correct permits in due time, so that they can be processed in time. When you make the tender, be adamant about important stuff. So I've talked to some construction companies that say that they want a financial carrot if they are able to distinguish sand from gravel from soil, and others say that that they're already good at it, so they need more like a fine if they don't do it right. This is some things that you can consider for the tender, whether you should go with the carrot or the fines, and how to make sure that important things for uh, soil reuse being um, are being made in due time on the construction site. Finally, you can also uh, consider that establishing the site and running it might not necessarily be the same task. That could be if there are not a construction company big enough locally to do both, or if you have any inputs as to which companies would be best suited for one or the other part. It doesn't necessarily have to be the same thing. You could also discuss with the different people that are part of the process that risk sharing is something that you could consider, because when you do things differently than you're used to, new risks appear. They might not be big, but when people don't know them, they're reluctant to take on those risks. So risk sharing is very important, and what you could do is save the cost savings and then say that they can cover some of the risk later on if they turned out to be important. And then finally, you can consider more than soil. So let's say that you can actually keep more different types of materials on that site than just soil. If that makes sense, you should definitely do that. So the conclusions. The best case scenario from the case I just showed you were up to 70% CO2 emission savings. It is definitely possible, and this is one way of contributing to circularity in construction projects. It's a multi-subject discipline. Bring people together to solve it. This is also what makes projects like this fun to be part of. And the overall advice is map out what needs to happen, because it takes a lot of people involved, a lot of different people, and everybody needs to see their place in the process, and abandon business as usual. Then I'm just going to show you this. It's not very pretty, but this is just the path that I drew up with some stakeholders a while back for when you're going from idea to a local resource site. And I have some translations here. You put in what you want, so the idea, then you bring in stakeholders and define all the goals. That allows you to talk to authorities and apply for permits. And then you make a tender for the project itself. You accumulate everything and you bring it to life, and then you repeat it, because then finally this will be the new way of going about construction projects with excess soil. I'll take your questions.
Thank you, Isaac. Fantastic presentation. We just have a few minutes for some question and answers. Thank you for logging some questions already. You can continue to log your questions in the question box on the control panel, and also you can find the presentation slides available in the handout box. I will start with the first question. What measures improve the local soil management and lower CO2 emission?
Well, I think this was covered pretty well in the presentation, because what we found was that the main emissions from the construction project where there's soil excavation is the transport of the soil. So the measures that lowers the CO2 is to keep it close to the site. That lowers the emissions from transport. Yeah.
Thank you. There are some questions here about the methods that you're using to treat soil after excavation.
Yes. I touched on that only briefly. And a typical one that we see in Denmark is that you add burnt chalk to stabilize the soil geotechnically, meaning that you add it if it's not suited for reuse in construction. If it doesn't have the load bearing capacity you need, you can add burnt chalk. That has to be clay soil for that to work. Sometimes it's enough just to add some sand or some gravel to the soil. Sometimes that's enough. That's what you should prefer. You can also add cement, but uh, that is kind of the same downsides with cement as it is to burnt chalk. Is it has a very high CO2 load, but it's more efficient in the same time. So you shouldn't rule it out, but the focus on the methods that doesn't emit so much CO2, and that also maybe are already materials from the excavation that you can reuse after you sort it on the site. So that was sand and gravel.
Thank you. Next question is, how do you address storage of soil materials that can be reused, but the problem is with an area with limited ground? Limited ground.
Yeah, That's a very good question, and that's something that often comes up because if you're in rural areas, you don't really just have an excess field in the neighborhood. And in that sense, it's difficult. But as I mentioned, I've seen calculations from other people showing that if you can do a site within 15 kilometers, so that would be around 10 miles, it would still have a CO2 positive perspective. Um, on the other hand, maybe you don't even have that. And what I've been discussing with authorities was if we were allowed um, to use a parking lot, for example, um, for a limited time space, that will probably turn out to be difficult because you will definitely need more permits, not less, which increases kind of the workload to perform a project like this. But on the other hand, we've seen the LCA calculations showing the huge CO2 emission benefits by reusing soil locally. So that would probably be my way to go about it, to see if I could find some parking spaces or other spaces that would be able to be rented for a limited period.
Thank you. You touched on some risks. What are the main risks compared to doing construction projects as business as usual?
Yes, I mean, I would say the main risk is that you're doing something that is still kind of new. So you don't have all the experience that you do with the business as usual models. And that means when you don't have the experience, we need to be more conservative when we assess risks because we don't have as much to base it on. So it means that all of the participants in projects like this have to take on more risks. So one risk could be if we have some excess soil and we sort it on the local site and we add, let's say, burnt chalk to geotechnically improve it, will that be good enough as, let's say, stable gravel that we bought from a gravel pit? And it's questions like this that amounts to kind of more risk on the project. And we need people to accept that because it's difficult. If nobody accepts it, it's difficult to move forward. But on the other hand, if we get a financial benefit from doing it in a new way, then some of that benefit, some of that financial surplus can be used to mitigate the risks and handle the risks if they turn out to be something that actually changes the project or something that we need to fix afterwards.
Thank you. I will take the last question, and all additional questions that were asked will be followed up by the presenter. The question here is about complexity versus benefits. It says, isn't it very complex to reuse soil locally like you propose versus the benefits here?
That is a very good question because I think nobody are in doubt that it is more complex to reuse soil with a local site for doing this. So I would say, in my opinion, it's definitely worth it because the benefits are so big and we need to move towards circularity. And this is a step in construction. And I don't know how we can otherwise uh, reach the goal of circularity in construction projects with excess soil. So I think it's worth the benefit. But another thing that I could mention here is that this local soil improvement site that I've been talking about today with the Videlev case is just for one case. It's definitely doable to do sites that work with a lot of different construction projects. And you can even do sites in municipalities that will be permanent and will handle all the soil from all the local construction projects eh, in that municipality. And in that way, it will become less of a hassle and it will um, be an improvement to all the different projects that will use it.
Thank you, Isaac, for your fantastic presentation, and thank you everyone for joining us today. You can still reach out to Isaac via the contact details that are shown on the screen. So we will wrap up the session now. Again, big thanks for your time today. Have a wonderful day, everyone. Thank you.